March 8, 1944, 24,000 feet above the frost-covered farmland of northern France, the morning sun catches the aluminum skin of a formation of Republic P-47 Thunderbolts as they patrol the bomber stream returning from Augsburg. The air at this altitude cuts like razors, the oxygen thin and cold enough to freeze moisture in a man's lungs. In the cockpit of Big-Ass Bird Roman II, Lieutenant Robert Johnson scans the crystalline sky through his windscreen, watching vapor trails sketch white lines against the infinite blue. Then he sees them, a swarm of Focke-Wulf 190, their mottled gray camouflage barely visible as they position themselves above and behind the American formation. The German pilots are confident, experienced veterans of the Eastern Front, men who have learned that altitude equals life, that the fighter who strikes from above holds every advantage. They begin their attack run, diving toward what they believe will be easy prey. The big American fighters they mockingly call jugs, fat and slow, surely incapable of matching the diving performance of their sleek Focke-Wulfs. What happens in the next 90 seconds will shatter that confidence forever, as Johnson pushes his control stick forward, and 7 tons of American engineering accelerates downward with a velocity that defies every principle these German pilots thought they understood about aerial combat. This moment crystallized a technological revolution that would fundamentally alter the mathematics of air warfare over Europe. The Republic P-47 Thunderbolt, mocked in its early service days as too large, too heavy, too slow to climb, had evolved into something the Luftwaffe had not anticipated. A fighter capable of converting mass into momentum with such devastating efficiency that German pilots found their traditional escape tactics transformed from reliable survival strategies into death sentences. The P-47D variant that Johnson flew weighed 500 pounds fully loaded, making it the heaviest single-engine fighter in operational service anywhere in the world. German fighter doctrine, refined through 4 years of combat across 2 continents, emphasized the importance of energy management, the careful conservation and expenditure of altitude and speed to maintain tactical advantage. But the P-47 operated according to different physics, exploiting its tremendous mass through the elegant application of gravity, becoming in a dive not merely fast but overwhelming, a 7-ton meteor that accelerated beyond the escape velocity of any Luftwaffe fighter then flying. The aircraft that Johnson flew that morning over France was the product of an engineering philosophy that seemed almost perversely American in its approach to fighter design. Where European fighters emphasized lightness, agility, and careful optimization of power-to-weight ratios, Republic Aviation had built something fundamentally different. A fighter that embraced weight, that weaponized mass, that turned what should have been a disadvantage into the cornerstone of a tactical revolution. The heart of this philosophy was the Pratt & Whitney R2800 double Wasp radial engine, a mechanical marvel that produced 2 535 horsepower at war emergency power, driving a 4-bladed Curtiss electric propeller 13 feet in diameter. This massive power plant didn't just move the P-47, it hurled it through the air with a thrust-to-weight ratio that, while modest in level flight, became extraordinary when gravity joined the equation. The turbocharger system, hidden in the fuselage behind the pilot, fed compressed air to the engine even at extreme altitudes, maintaining full power where German fighters began to gasp for oxygen. At 25,000 feet, where Focke-Wulf 190s and Messerschmitt 109 struggled to maintain performance, the Thunderbolt was just reaching its optimal operating envelope. The German pilots begin their attack dive, confident in the knowledge that has kept them alive through hundreds of combat missions, that a Focke-Wulf in a dive can outrun anything in the sky. Oberleutnant Klaus Mayarush, leading the swarm, has 72 victories to his name, most of them against Russian fighters on the Eastern Front. He has survived Stalingrad, Kursk, the meat grinder of aerial combat over the motherland, where German tactical superiority was the only thing keeping him alive. He knows his FW-190A8 can dive at speeds approaching 475 miles per hour, fast enough to escape any pursuer, fast enough to dictate the terms of engagement. He watches the American fighters grow larger in his Rivy gunsight, preparing to open fire with his 4 20mm cannons and 2 13mm machine guns at optimal range. Then something happens that his combat experience has not prepared him for. The lead American fighter doesn't attempt to turn, doesn't try to climb away, doesn't follow any of the defensive maneuvers that Meteors has learned to anticipate and counter. Instead, it simply rolls inverted and points its massive nose straight down toward the Earth 4.5 miles below. What Oberleutnant Meteors could not know, what German intelligence had failed to properly analyze, what Luftwaffe tactical doctrine had not yet incorporated, was that the P-47 Thunderbolt possessed a diving capability that bordered on the supernatural. On November 13, 1942, test pilots Harold Comstock and Roger Dyar had pushed a P-47B into a vertical dive from 35,000 feet, accelerating until their airspeed indicators registered 725 miles per hour, more than 12 miles per minute, approaching Mach 1 at that altitude, faster than the speed of sound at sea level. The aircraft had exceeded its theoretical maximum dive speed by more than 200 miles per hour, entering a realm of compressibility where control surfaces became sluggish and airframe stress threatened structural failure. Yet the Thunderbolt had held together, and when Comstock and Dyar finally pulled out at 5,000 feet, experiencing G-forces that grayed out their vision and pressed them into their seats with the weight of multiple men, the aircraft was still flying, still controllable, still deadly. Republic Aviation had built not just a fighter, but a tactical weapon that rewrote the rules of aerial combat, transforming the vertical dimension of the sky from a realm of careful energy management into a domain where mass and gravity combine to create overwhelming velocity. The dive begins with deceptive gentleness. Johnson pushes the stick forward smoothly, feeling the nose drop below the horizon, watching the airspeed indicator begin its steady climb. At first, the acceleration seems almost modest, 350 miles per hour, 375, 400. The Focke-Wulf behind him follows, Meteors confident that he can match or exceed whatever speed the American achieves. But then the mathematics of mass and gravity assert themselves with mathematical inevitability. The P-47, 7 tons of aluminum, steel, armament, fuel, and pilot begin to fall not like an aircraft, but like a stone. Its tremendous weight overwhelming aerodynamic drag, its powerful engine adding thrust to gravity's pull. The airspeed indicator sweeps past 450, then 475, then 500 miles per hour. The aircraft begins to buffet, the airframe protesting as it enters speeds for which level flight aerodynamics offer no preparation. The stick grows heavier, the controls less responsive, as compressibility effects begin to assert themselves at the shock wave forming over the wings. But the aircraft holds together, engineered to withstand stresses that would tear apart lighter, more delicate fighters. The physical forces acting on Johnson's aircraft in this dive represented a confluence of engineering and physics that German aircraft designers had not fully appreciated. The P-47's wing loading, the ratio of aircraft weight to wing area, was 2 pounds per square foot, significantly higher than the Focke-Wulf 190-35, 5 or the Messerschmitt 109-32, 3. In level flight, this translated to reduced maneuverability and slower rate of turn. But in a vertical dive, higher wing loading became an advantage, allowing the aircraft to accelerate faster and reach higher terminal velocities before aerodynamic drag balanced gravitational force. The Thunderbolt's robust all-metal construction, built to withstand the stresses of ground attack missions carrying 500 pounds of bombs and rockets, provided structural margins that German fighters, optimized for weight reduction, could not match. Republic's engineers had overbuilt the P-47, creating an airframe capable of sustaining 9G maneuvers when most fighters of the era were stressed for 6 or 7 Gs. This structural strength meant that a Thunderbolt pilot could push his aircraft harder, dive steeper, pull out more violently, without fear that the wings would separate or the fuselage would buckle. Behind and above, Meteors watches with growing alarm as the American fighter accelerates away from him. His Focke-Wulf, lighter and more agile at lower speeds, cannot match the P-47's diving acceleration. The American grows smaller in his gunsight, pulling away with a speed that seems impossible for such a large aircraft. Meteors advances his throttle to full power, steepens his own dive, but the gap continues to widen. At 18,000 feet, the P-47 is 600 yards ahead and still accelerating. At 15,000 feet, the gap has opened to 1,000 yards, and the American has become a tiny speck against the patchwork farmland below. The physical reality is undeniable. The American fighter is faster in a dive than his Focke-Wulf, faster by a margin that cannot be overcome through pilot skill or tactical positioning. For the first time in his combat career, Meteors experiences a sensation he has not felt since his earliest days of flight training. The helpless recognition that his aircraft is simply outperformed, that no amount of experience or courage can compensate for fundamental technological inferiority. This moment of recognition, replicated in hundreds of encounters across the skies of Europe throughout 1944, represented a psychological transformation as significant as the tactical one. German fighter pilots had entered the war confident in the technical superiority of their aircraft, particularly in the diving performance that allowed them to attack and disengage at will. The Messerschmitt 109 and Focke-Wulf 190 had dominated opponents through superior energy management, using vertical maneuvers to dictate the terms of engagement. But the P-47 disrupted this calculus completely. Kurt Bühleisen, a Luftwaffe ace credited with 112 aerial victories, later recalled the transformation forced upon German tactics. "We learned not to dive away from a P-47. It was suicide. The Thunderbolt would simply accelerate faster, close the distance, and its 850s would cut you to pieces before you could recover. We had to change everything. Turn into them, force them into turning fights where their weight became a disadvantage. But that meant abandoning our altitude advantage, fighting on American terms, accepting risks we had always avoided." At 12,000 feet, Johnson begins his pullout, hauling back on the control stick with both hands, feeling the G-forces multiply as 7 tons of aircraft changes vector from vertical to horizontal. The blood drains from his head, his vision tunnels, the edges of his world graying out as his cardiovascular system struggles to pump oxygen-rich blood against gravitational force multiplied by violent maneuvering. But the Thunderbolt's robust structure holds. The wings flex but do not fail. The fuselage remains intact despite stresses that would crumple lighter airframes. The recovery is violent, physically punishing but successful. At 8,000 feet, Johnson is level again, his airspeed still indicating 440 miles per hour, his position reversed. He is now behind and below the German formation that attempted to bounce him, and he is faster, carrying more energy, holding every tactical advantage. The sound that defined the P-47 in dive was not a scream, but a roar. The deep-throated bellow of the massive R-2800 engine at full power, combined with the rushing wind over the aircraft's bulbous fuselage and broad wings. Ground observers described it as the sound of tearing fabric amplified 1,000 times, or distant thunder that built to overwhelming crescendo. German soldiers on the Eastern Front, veterans of 3 years of mechanized warfare, claimed they could distinguish the sound of diving P-47 from any other aircraft, a distinctive rumble that announced incoming ground attack with the inevitability of an avalanche. This acoustic signature became psychologically devastating, a Pavlovian trigger that announced impending destruction to ground troops and fighter pilots alike. The sound represented not just approaching danger but unstoppable momentum, the audible manifestation of 7 tons of aircraft accelerating past the point where traditional tactics could offer response or escape. Johnson arms his 8 Browning M2, 50 caliber machine guns, 4 in each wing, each weapon fed by belts holding 425 rounds. The total ammunition load is 400 rounds, enough for more than 30 seconds of sustained fire at the weapon's combined cyclic rate of 800 rounds per minute. Each projectile weighs 7 ounces, traveling at 900 feet per second when it leaves the barrel, carrying kinetic energy sufficient to punch through aluminum skin, shatter engine blocks, sever control cables, and set fuel tanks ablaze. The convergence point, the distance at which all 8 guns concentrate their fire, is set for 300 yards, creating a cone of destruction approximately 6 feet in diameter where 113 rounds per second intersect. The ballistic computing site, crude by later standards but revolutionary for 1944, helps Johnson calculate the lead angle necessary to intercept a target moving at hundreds of miles per hour. He selects the trailing Focke-Wulf in the German formation, the pilot who had been wingman to Meteors, who is now desperately trying to dive away from the American fighter that has somehow materialized behind his formation. The firepower concentrated in the P-47's wings represented American industrial might, translated into aerial combat effectiveness. Each 50 caliber Browning was a masterpiece of precision manufacturing. capable of firing 850 rounds per minute with remarkable reliability, even in the extreme cold and vibration of high-altitude combat. The ammunition was equally sophisticated, armor-piercing incendiary rounds that could penetrate the steel armor protecting German cockpits and engines, then ignite fuel or hydraulic fluid with white-hot fragments. High-explosive incendiary rounds that detonated on impact, creating devastating secondary effects inside the thin aluminum skin of enemy aircraft. Tracer rounds loaded at intervals to mark the trajectory of fire, creating the signature hose of lead effect that pilots used to walk their fire onto target. The total weight of projectiles fired per second, 7 pounds, exceeded the payload weight of a human being, a continuous stream of destruction that could saw through a fighter's wing or ventilate a cockpit in fractions of a second. The Focke-Wulf pilot never sees the P-47 that kills him. He is focused on his own dive away, following the doctrine that has always worked before. Dive to maximum speed. Use the FW-190 excellent roll rate to brake left or right. Force the pursuer into a turning fight where the American's weight becomes liability rather than asset. But Johnson doesn't need to turn. He has speed, position, and overwhelming firepower. At 400 yards, he opens fire with a 2-second burst, walking the incandescent stream of tracers into the Focke-Wulf's fuselage. 226 rounds, 14 pounds of metal moving at 3 times the speed of sound, intersect the German fighter at its thickest cross-section. Armor-piercing rounds punch through the FW-190 rear fuselage armor. Others strike the engine, the wing root, the cockpit canopy. One round severs the elevator control cable. Another ignites hydraulic fluid in the pressurized lines. A third passes through the pilot's seat and into his body, its passage creating a temporary cavity that destroys organs even where direct trauma would be survivable. The Focke-Wulf begins to come apart in midair, pieces separating from the airframe as overstressed structures fail, as fire spreads through punctured fuel tanks, as the pilot's last conscious moments are consumed by pain and confusion, and the terrible recognition that he is already dead. The tactical revolution represented by this engagement pattern, dive, overtake, destroy, echoed across every combat theater where P-47s operated throughout 1944 and 1945. In the European theater alone, Thunderbolts claimed 3 752 aerial victories against Luftwaffe fighters, destroying more German aircraft than any other Allied fighter type. The loss rate was remarkably low, 0.7% per mission, partially because P-47 pilots could dictate engagement terms, attacking when they held advantage and diving away when circumstances turned unfavorable. German pilots, forced to abandon their traditional boom and zoom tactics, found themselves fighting on American terms, accepting turning engagements where their superior maneuverability was partially offset by the P-47's superior firepower and structural strength. Luftwaffe training doctrine underwent fundamental revision as the tactical implications of the P-47's diving performance became clear. Avoid diving away, turn into attacks, force close-range maneuvering combat, attack in overwhelming numbers, strike bomber formations, and disengage immediately if escorts intercept. Each revision represented acknowledgement that German tactical superiority, maintained through 4 years of combat, was eroding under the weight of American industrial and technological capability. The remaining German pilots scatter, abandoning formation discipline in desperate attempts at individual survival. Meteors rolls his Focke-Wulf into a sharp left turn, pulling maximum G-force, accepting the energy bleed in exchange for changing his vector away from the American behind him. His wingman attempts a split S, rolling inverted and pulling down, trading altitude for airspeed in a maneuver that has saved his life a dozen times before. But Johnson's element leader, Captain Gerald Johnson, no relation, is already there, having dove from altitude with his wingman, both P-47s accelerating past 500 miles per hour in their vertical approach. Gerald Johnson opens fire at 350 yards, his 850s creating a cone of destruction through which the inverted Focke-Wulf must fly to complete its maneuver. The German pilot never completes the split S. Cannon shells from his own guns cook off as fire spreads through the wing ammunition bays, creating secondary explosions that tear the wing from its mounting. The Focke-Wulf tumbles, pieces separating, the pilot either dead or unconscious or simply beyond the capacity to respond, as his aircraft disintegrates around him. The psychological impact of this tactical dominance extended beyond individual engagements to affect Luftwaffe strategic planning and force allocation. By mid-1944, German fighter commanders faced an impossible calculus: defend against American heavy bombers with their massed defensive firepower, or attack the P-47 escorts that could dive through defensive formations with impunity. The traditional Luftwaffe doctrine of attacking bomber formations from head-on, diving through the formation to attack from below, became suicidal when Thunderbolts were present. P-47s would dive after the attacking fighters, accelerate to overtaking speed, and destroy them before they could recover from their own attack runs. German pilots increasingly chose to avoid combat entirely when P-47s were detected, conceding air superiority rather than accepting losses in encounters they could not win. This defensive mentality represented a complete reversal from the aggressive fighter tactics that had defined Luftwaffe doctrine through the war's first 4 years. The transformation was captured in a Luftwaffe intelligence assessment from July 1944. The P-47 must be considered the most dangerous American fighter at altitudes above 15,000 feet. Its diving performance exceeds all German fighter types by substantial margin. Engagement should be avoided unless numerical superiority exceeds 3. An attack can be pressed home before escort intervention. Meteors survives this engagement, one of the few German pilots with sufficient skill and combat experience to recognize the transformed tactical situation and adapt accordingly. He forces his Focke-Wulf into a climbing spiral, trading his remaining airspeed for altitude, accepting vulnerability in the vertical plane in exchange for forcing the P-47s into a turning fight, where their superior diving performance offers no advantage. Robert Johnson, assessing the situation with the cool calculation that will earn him 27 aerial victories before his tour ends, chooses not to pursue. He has destroyed one enemy fighter, damaged another, broken up the German attack on the bomber stream. His fuel state is adequate but not generous, his ammunition depleted by 30%, his tactical position favorable but not overwhelming. The P-47's combat radius, even extended by the belly tank carrying an additional 150 gallons, means every minute of combat consumes fuel needed for the return to England. Johnson rolls his flight back toward the bomber stream, resuming escort position, allowing the surviving German pilots to disengage. The engagement has lasted 4 minutes from initial contact to final separation. 2 German fighters are destroyed. 1 pilot is dead. Another is parachuting toward an uncertain fate in occupied France, and the tactical calculus of air superiority over Europe has shifted fractionally but measurably in favor of the Americans. The recurring symbol that defined the P-47's impact on aerial combat was not the aircraft itself, but the sound of its dive. That distinctive roar that announced to friend and enemy alike that the mathematics of survival had changed, that altitude and position no longer guaranteed advantage, that weight and power could transform the vertical dimension of the sky into a lethal domain where traditional tactics offered no escape. German ground troops learned to recognize that sound, to take cover when it approached, to know that the roar would be followed by rockets, bombs, and machine gun fire that transformed roads into kill zones and armor columns into funeral pyres. German fighter pilots learned to fear that sound above all others, because it announced that a 7-ton meteor was diving toward them at speeds their own aircraft could not match, carrying firepower that could cut their aircraft in half, flown by pilots who had learned to weaponize mass and velocity with devastating efficiency. By late 1944, the tactical transformation forced by the P-47's diving capability had become so complete that Luftwaffe training doctrine explicitly prohibited diving away from American fighters. Student pilots in combat schools learned that the instinct to dive for safety, reliable against Soviet fighters, effective against early-model American fighters, had become a death sentence against Thunderbolts. New tactics emphasized turning into attacks, forcing horizontal maneuvering combat, accepting the energy loss in exchange for negating the P-47's primary advantage. But these tactical adaptations came too late and achieved too little. American numerical superiority, industrial capacity, and pilot training quality meant that even when German pilots fought on favorable terms, they faced opponents with more fuel, more ammunition, more aircraft, and, increasingly, more experience. The P-47 technical advantages simply amplified the broader strategic reality that Germany was losing the air war through attrition it could not replace, against opponents who could afford losses and still maintain overwhelming force. The engineering that enabled the P-47's diving performance represented American industrial philosophy made manifest in aluminum and steel. Republic Aviation had not set out to build a dive bomber masquerading as a fighter. They had designed a high-altitude escort fighter optimized for bomber protection. But American engineering culture, pragmatic, empirical, willing to accept weight and complexity in exchange for capability, had created something more significant than its designers intended. The massive R-2800 engine, chosen for its power and reliability rather than optimal power-to-weight ratio, provided thrust reserves that complemented gravity rather than fighting it. The robust airframe, over-engineered to provide margin for unknown combat stresses, could survive forces that would destroy lighter aircraft. The sophisticated turbocharger system, adding weight and mechanical complexity, maintained performance at altitudes where enemy fighters struggled. Each design decision, made for sound engineering reasons, combined to create an aircraft that excelled at something its designers had not specifically intended, converting altitude into devastating kinetic energy through the elegant application of gravity. The broader strategic implications of the P-47 tactical advantages extended beyond individual combat engagements to affect the fundamental balance of the air war over Europe. By mid-1944, the Luftwaffe had been forced into defensive posture, husbanding remaining resources for the defense of the Reich itself, conceding air superiority over occupied territories where American and British fighters operated with impunity. The P-47 Thunderbolt, initially dismissed by critics as too heavy and too short-ranged for escort duties, had evolved into the primary ground attack aircraft of the American Tactical Air Forces, a role for which its robust construction and heavy armament proved ideal. Fitted with external fuel tanks, rockets, and bombs, P-47s ranged across France and Germany, destroying trains, trucks, armor, bridges, and airfields with an efficiency that Wehrmacht ground commanders found impossible to counter. The same diving capability that made it deadly in air combat translated to devastating effectiveness in ground attack. P-47 would roll into vertical dives from 8,000 feet, accelerate to 450 miles per hour, release bombs or rockets with accuracy impossible at lower speeds, then pull out at 2,000 feet and strafe with their 850s before climbing back to altitude. German flak crews found the diving P-47 nearly impossible to hit. Their tremendous speed and robust construction meant that even direct hits often failed to down the aircraft. The statistical record of P-47 operations told a story of overwhelming effectiveness, achieved through the combination of technical capability and tactical innovation. Between April 1943 and May 1945, P-47 Thunderbolts flew more than 500 combat sorties in the European theater alone. They claimed 752 aerial victories against 499 aircraft lost to all causes, combat, accidents, mechanical failure, and weather, for a kill ratio of 1.07 in aerial combat alone. When ground victories were included, locomotives, trucks, tanks, and static targets destroyed by ground attack, the effectiveness ratio became overwhelming. A single P-47 squadron, the 56th Fighter Group, claimed 1,006 aerial victories and more than 200 ground victories over a 2-year combat period. The aircraft's loss rate per mission, 0.7%, was among the lowest of any fighter type operating in the European theater, a testament to its structural strength and the tactical advantages its diving performance conferred. German pilots, forced to engage on unfavorable terms or concede air superiority entirely, found themselves in an unwinnable tactical situation that mirrored the broader strategic reality of Germany's war position. The testimony of surviving German pilots, recorded in post-war interrogations and memoirs, revealed the psychological impact of facing an opponent whose technical capabilities exceeded their own in decisive ways. Major Hans-Eckhard Bob, a Luftwaffe ace credited with 60 victories, later described his encounters with P-47s in terms that acknowledged both respect and frustration. The Thunderbolt was not the best turning fighter, not the fastest in level flight, not the most beautiful aircraft, but it was the most effective combat machine we faced. It could absorb damage that would destroy any German fighter. Its diving speed was impossible to match. Its firepower was devastating. 8 heavy machine guns that could destroy a fighter with a single burst. And there were always more of them. We would shoot down 1, 2, 3, but more would always appear. And they always had fuel and ammunition while we were running out. Fighting the P-47 was like fighting the American industrial machine itself. Overwhelming, unstoppable, inevitable. The transformation of the P-47 from mocked jug to respected adversary paralleled the broader transformation of American air power from quantitative mass to qualitative superiority. Early Thunderbolts, the P-47B and C variants, had been plagued by technical problems, limited range, and poor climb rate that made them less effective than the Spitfires they were meant to replace. Pilots complained about poor visibility from the Razorback canopy, inadequate range even with external tanks, and climb performance that left them vulnerable to German fighters during initial engagements. But American engineering culture, responsive to field feedback and willing to iterate rapidly, transformed the aircraft through continuous improvement. The bubble canopy of the P-47D dramatically improved visibility. Paddle blade propellers increased propulsive efficiency by 15%. Water injection systems boosted emergency power to 535 horsepower. Improved supercharger systems extended combat radius to more than 1,000 miles with external tanks. Each modification addressed real combat shortcomings identified by pilots and maintenance personnel, creating an aircraft that evolved to meet operational requirements rather than conforming to pre-war doctrinal assumptions. The sound of diving P-47 became the audible signature of American air superiority over Europe in 1944 and 1945. A roar that announced to everyone beneath its shadow that the terms of combat had changed, that the Luftwaffe's vaunted tactical superiority had been eroded by American industrial capacity and technical innovation. German soldiers learned to distinguish that sound from the scream of diving Stukas or the whistle of falling bombs, learned to recognize it as the herald of attack that would come too fast and too hard for traditional anti-aircraft defenses to counter. Allied soldiers celebrated the sound, knowing it meant that their ground advances would be covered by fighters that could dominate German aviation and destroy German ground forces with equal effectiveness. The psychological impact of air superiority, the knowledge that friendly aircraft controlled the sky while enemy aviation had been reduced to sporadic, ineffective resistance, provided intangible but decisive combat advantage to Allied ground forces throughout the final year of the European War. The technical evolution of American fighter tactics, driven by the P-47's capabilities and limitations, represented a microcosm of American military adaptation throughout the war. American pilots, trained in doctrine that emphasized formation integrity and mutual support rather than individual aerial combat, initially struggled against German pilots whose tactical sophistication reflected 4 years of combat experience. Early exchange rates favored the Luftwaffe. Experienced German pilots could exploit the P-47's poor climb rate and limited low-altitude performance to achieve favorable outcomes even when outnumbered. But American tactical doctrine evolved rapidly, incorporating lessons learned at terrible cost into revised training programs and operational procedures. Pilots learned to exploit the P-47's diving performance, to use altitude advantage to offset inferior climb rate, to leverage overwhelming firepower and robust construction to survive encounters where German fighters would be destroyed. The dive and zoom, tactics that became standard for Thunderbolt operations, transformed the P-47's weight from liability to asset, allowing American pilots to dictate engagement terms and disengage when circumstances turned unfavorable. The industrial dimension of the P-47's effectiveness extended beyond individual aircraft performance to encompass the entire American production and logistics system. Republic Aviation's factories in Farmingdale, Long Island, and Evansville, Indiana, produced 683 Thunderbolts between 1942 and 1945. An average of more than 14 aircraft per day over the 3-year production run. This industrial capacity meant that P-47 losses, severe as they seemed to individual squadrons, could be replaced faster than German forces could inflict them. A squadron that lost 4 aircraft in a single mission would receive replacement aircraft within days, while Luftwaffe units that lost 4 fighters might wait weeks or months for replacements. The logistical system supporting P-47 operations was equally impressive. Spare parts, ammunition, fuel, oxygen, and maintenance supplies flowed across the Atlantic in quantities that German logistics could not match even for operations within Germany's own borders. Each P-47 mission consumed 200 gallons of high-octane aviation fuel, 400 rounds of 50 caliber ammunition, and required 20 man-hours of maintenance between sorties. American logistics made these requirements seem routine. German logistics struggled to provide basic fuel and ammunition for increasingly desperate defensive operations. The broader context of air warfare in 1944 revealed how the P-47's technical advantages combined with American strategic superiority to create an operational environment where German defeat became mathematically inevitable. The combined bomber offensive, striking German industrial targets around the clock with British bombers by night and American bombers by day, forced the Luftwaffe into defensive battles it could not win. German fighters, rising to defend their homeland, faced American escorts with numerical superiority, superior logistics, and in the P-47, technical capabilities that negated traditional German tactical advantages. The attrition was unsustainable. Germany produced 285 single-engine fighters in 1944, an impressive feat given the disruption of German industry by Allied bombing. But losses exceeded production. Experienced pilots were killed faster than replacements could be trained. Fuel shortages limited training flight hours, ensuring that new pilots arrived at combat units with inadequate experience. The Luftwaffe fighter force, despite increased production, actually decreased in operational effectiveness throughout 1944, as experienced pilots were killed and replaced by inadequately trained novices flying aircraft hampered by fuel shortages. The testimony of American pilots who flew the P-47 in combat consistently emphasized the aircraft's survival characteristics over its performance specifications. Lieutenant Colonel Francis Gabreski, leading ace of the 56th Fighter Group with 28 aerial victories, described the Thunderbolt in terms that captured its essence. The P-47 wasn't the fastest or the prettiest, but it was the toughest and most reliable fighter in the sky. You could dive it past the red line, and it wouldn't come apart. You could take hits that would down any other fighter and still make it home. You could carry bombs and rockets and still fight German fighters on equal terms. It was a pilot's airplane, forgiving of mistakes, responsive to skill, survivable when luck ran out. I saw P-47s come back with cylinders shot out, wings holed, tail surfaces shredded, and still fly well enough to land safely. That kind of survivability gave you confidence to press attacks, to take risks, to fight aggressively because you knew the airplane would get you home. The symbolic power of the diving P-47, that roaring meteor that accelerated past the point where German fighters could follow, represented more than tactical advantage or technical capability. It embodied the fundamental difference between American and German approaches to warfare, between industrial democracy and authoritarian militarism. The P-47 was not built around elegant theories of optimal design or refined aesthetic principles. It was built to win, using whatever combination of power, weight, and firepower achieved that objective. It embraced mass where German designs emphasized lightness, accepted complexity where German engineers sought simplicity, prioritized survivability and firepower over maneuverability and speed. This pragmatic engineering philosophy reflected the broader American approach to the war. Apply overwhelming industrial capacity, accept material costs in exchange for reduced casualties, iterate rapidly based on combat feedback, prioritize effectiveness over theoretical optimality. The result was an aircraft that shouldn't have been as effective as it was, but which dominated its opponents through the sheer weight of American industrial capability and tactical adaptability. By war's end, the P-47 Thunderbolt had destroyed more enemy aircraft than any other American fighter. 7,067 confirmed aerial victories, plus thousands more ground victories against locomotives, vehicles, and armor. It had flown more than 500,000 combat sorties across every theater of the war, from the freezing skies over Germany to the sweltering jungles of Burma and the Philippines. It had demonstrated that American industrial and technical capability could not only match, but exceed the best that German and Japanese aviation could offer. But perhaps its most significant contribution was not counted in victories or sorties, but measured in the transformation it forced upon enemy tactics and strategy. The Luftwaffe, facing fighters that could dive faster, shoot harder, and survive more damage than their own aircraft, had been forced to abandon offensive operations and fight a defensive war of attrition they could not win. German pilots, no matter how skilled or experienced, found themselves outmatched by American pilots flying aircraft that gave them decisive tactical advantages in the vertical dimension of combat. The sound of diving P-47 became the audible signature of this transformation, the roar that announced not just approaching combat, but the inevitable defeat of German aviation and the triumph of American industrial democracy. The mathematical reality of the air war over Europe in 1944 revealed how completely the P-47 and its sister American fighters had achieved air superiority. In January 1944, the Luftwaffe could field approximately 650 single-engine day fighters on the Western Front. By December 1944, despite increased production, operational strength had fallen to fewer than 200 aircraft, with serviceability rates below 60% due to fuel shortages and maintenance difficulties. American fighter strength over the same period increased from 200 aircraft in January to more than 3,000 by December, with serviceability rates exceeding 85%. The exchange ratio in aerial combat, American aircraft lost per German aircraft destroyed, improved from approximately 1 in early 1944 to better than 1.4 by war's end. This attrition could not be sustained. Germany lost approximately 500 fighter pilots killed in action during 1944, more than the total number of experienced pilots available at the year's beginning. American losses, while numerically greater, represented a smaller percentage of total available pilots and were replaced more rapidly by training programs that produced more than 100,000 pilots during the war years. The final testament to the P-47's impact came not from American sources, but from German recognition of its effectiveness. Hermann Göring, commander of the Luftwaffe, reportedly stated in late 1944 that, "When I saw Thunderbolts over Berlin, I knew the war was lost." Whether apocryphal or accurate, the statement captured the psychological impact of American fighters operating with impunity deep in German airspace, their diving attacks disrupting Luftwaffe defensive formations, their ground attacks paralyzing German transportation and logistics. The P-47 Thunderbolt, mocked in its early service as a flying milk jug, and written off by critics as too heavy and too limited for escort duties, had evolved into the aircraft that German pilots feared most, the fighter that forced Luftwaffe tactical doctrine to abandon offensive operations in favor of defensive measures that could not prevent inevitable defeat. The transformation from mocked jug to feared meteor had taken less than 2 years of combat operations, a transformation driven by engineering improvement, tactical innovation, and the overwhelming industrial capacity of American war production. In the cold assessment of military effectiveness, the P-47 Thunderbolt represented optimal translation of industrial capacity into combat power. It was not the fastest fighter. The P-51 Mustang was faster in level flight. It was not the most maneuverable. The Spitfire could outturn it at all altitudes. It was not the most elegant. Its bulky radial engine shape earned it the unflattering Jug nickname. But it was the most effective American fighter of the war when effectiveness is measured not by performance specifications, but by combat results. Victories achieved, missions completed, pilots returned safely. The P-47 shot down more enemy aircraft, completed more ground attack missions, and brought more pilots home safely than any other American fighter. It achieved this effectiveness not through optimization of any single capability, but through balanced integration of multiple advantages: devastating firepower, robust construction, reliable systems, and the diving performance that allowed pilots to dictate engagement terms. This balance of capabilities reflected American engineering philosophy and American industrial capacity, creating an aircraft that was greater than the sum of its specifications, that transformed weight and power into tactical dominance through the elegant application of gravity. And so the sound of diving P-47 Thunderbolts became the audible signature of American air superiority over Europe, the roar that announced transformed tactical reality, that forced German pilots to abandon strategies that had kept them alive through 4 years of combat, that proclaimed the triumph of American industrial democracy over German military tradition. It was the sound of 7 tons of aluminum, steel, and American engineering accelerating downward past the point where lighter, more elegant aircraft could follow, not through superior speed or power alone, but through the weaponization of mass itself, the transformation of weight from disadvantage to devastating advantage through the simple elegance of falling faster than opponents could flee. It was the sound of inevitable victory, achieved not through individual heroics or tactical brilliance, but through the systematic application of industrial capacity and engineering innovation to the problem of air superiority. It was the sound of freedom, messy, pragmatic, overwhelming, drowning out the last echoes of authoritarian militarism that had proclaimed technical and tactical superiority. It could not sustain against opponents who refused to fight on German terms. The roar of diving P-47 echoed across European skies for 18 months of intensive combat. And when it finally fell silent in May 1945, German aviation had been destroyed not through elegant tactics or superior individual skill, but through the grinding mathematics of industrial warfare. More aircraft, more pilots, more fuel, more ammunition, more everything, flown by men who had learned to transform the vertical dimension of the sky into a realm where gravity itself became an American weapon. And 7-ton meteors enforced the peace that follows absolute air superiority.